Find the point of inflection of g of x equals x squared minus 8 over x as long as 8 is positive. Now, points of inflection exist when the second derivative is equal to 0. So this is what I need to do. I need to take the first derivative and then the second derivative, set it equal to 0, solve, see what happens. G double prime of, G single prime of x. Actually, and I'm not even going to do that yet. I have to rewrite this guy out. So G of x is going to equal x squared minus 8x to the negative 1. So I can use power rule and power rule. G prime of x is going to be 2x, pretty easy. Drop down the negative 1, multiply it to negative 8, giving you positive 8x to the negative 2. G double prime of x is going to equal 2x, no, just 2, minus 16x to the negative 3. Okay? Now, set that equal to 0, and I'm going to rewrite this back as 2 minus 16 over x to the third power. So probably the easiest way of handling this is by adding 16 over x cubed to both sides, so it looks like that, and then multiplying both sides to x cubed like that. So then you have 16, and let's use a different color. 16 equals 2x cubed. Divide everything by 2. 16 is now 8, so let's not put 16 again. So 8 is equal to x cubed. Let's cube root both sides, and x is going to equal 2. So that's going to be u. So kind of a strange problem, but I liked it. I liked it a lot. Given f of x equals x cubed minus 3x squared plus 4, which of the following represents the intervals where the function is concave up? All right. So in order to find out if something is concave up, you need to take the second derivative and find the intervals where it's positive. So what I need to do first is take the first derivative. So f of x, or f prime of x, is going to be power rule 3x squared minus power rule 6x plus nothing. Let's take the second derivative, and f double prime of x is going to be power rule 6x minus 6. Now what we have to do is find our inflection points, and that's done by setting u equal to 0. So 6x minus 6. Add 6 to both sides, divide by 6, and my inflection point is going to be x equals 1. Now remember, inflection point means a change in concavity. So what I'm going to do is I'm going to make a sign chart for f double prime. I'm going to pick numbers like 0 and 10 and plug them into this formula right here to see if I get a positive or a negative number. A positive number means I get that concave up the way I want. A negative number means I get concave down. So if I plug in 0, f double prime of 0 is going to be 6 times 0 minus 6, which is negative 6, which is negative. Not what I want. F double prime of 10 is going to be 6 times 10 minus 6, which is 60 minus 6, which is 54, which is positive. And that happens at none of these. This happens from time to time where I try to get ChatGPT to make answers for me, and none of these are going to work out because the actual answer is going to be from 1 to infinity. So thanks a lot, ChatGPT. Your artificial intelligence, my foot. That's what I say. Thanks for watching. Like and subscribe. Given f of x equals 2x to the fourth minus 8x cubed plus 6, which of the following represents the intervals where the function is concave down? Well, in order to find out where something is concave down, you take the second derivative and find out where the second derivative is negative. In order to find the second derivative, we need to find the first derivative, which involves power rule, power rule, power rule. So you become 8x to the third minus 24x squared plus nothing. The second derivative is going to be power rule again, and that's going to be 24x squared minus 48x. Now what I need to do is find the inflection points, and the inflection points exist when the second derivative is equal to 0. So let's take this guy and set it equal to 0. 0 equals, let's factor out not only a 24 but also an x. So 24x times the quantity x minus 2. So my inflection points are going to be x equals 0 and x equals 2. So I'm going to make a sign graph for f double prime. 0 is a magic number, 2 is a magic number. And so what I'm going to want to do is plug in numbers in those intervals so I can find out where things are positive and where things are negatives in f double prime. So if I plug in -1, that'll be fine. And if I plug in regular 1, that'll be fine. And if I plug in 3, that'll be fine. So f double prime of -1, if I use this guy right here, which seems to be a little bit easier, so I'm going to use that. So that is still f double prime. I'm going to get 24 times -1, so -24. I'm going to get -1 minus 2, which is -3. And I don't care what number I get. I just know that this is positive. So you're going to be positive right here. So not at all what I want. F double prime of regular 1 is going to be 24 times 1, which is 24. And 1 minus 2, which is -1. 24 times -1 is -24, which is negative. So far, you are what I want, to quote a song from Greece. F double prime of 3 is going to be 24 times 3, which is 72. And 3 minus 2 is 1, so that's going to become positive, so you're going to become positive. So you are where we're concave down, between 0 and 2. Which is B. Okay? So yeah, that's how you do it. Fun stuff. Given f of x equals -x to the third plus 6x squared minus 9x, where is the function concave up and concave down? Well, my function is going to be concave up when the second derivative is greater than 0. It's going to be concave down when the second derivative is less than 0. So what I need to do in order to find the second derivative is I need to find the first derivative first. So f prime of x is going to equal power rule. -x cubed becomes -3x squared. Positive 6x squared is going to become plus 12x. Minus 9x is minus 9. Now my second derivative is going to be power rule again. So f double prime of x is going to be -6x plus 12 plus nothing. Okay, so what I have to do is I have to find my inflection points. My inflection points exist when f double prime of x is equal to 0. Okay, and I'm going to have one inflection point, -6x plus 12. I'm going to have one inflection point, and that's going to happen at, well, let's see, -12 minus 12, -12 equals -6x, divide by -6, divide by -6, x equals 2. So what I can do is I can make myself a sign chart for f double prime. 2 is my magic number. What I need to do is I need to find out where my second derivative is positive and where my second derivative is negative. I know it's 0 at 2. So if I were to take, like, I don't know, 0 and plug it in, or if I were to take 10 and plug it in, that'll help me figure out if this is positive or negative here, or if this is positive or negative here. So f double prime of 0 is going to involve me taking this guy right here and substituting in 0. -6 times 0 plus 12 equals positive 12, which means you are positive right here. F double prime of 10 is going to be -6 times 10 plus 12 is -60 plus 12, which is like -48, so definitely negative. So if your second derivative is positive, that means you are concave up. If your second derivative is negative, that means you're concave down. So we could say that we are concave up on the interval -∞ to 2, and we can say that we're concave down on the interval 2 to infinity. And this makes sense. This is a cubic. Cubic looks like this. So at some point here, and that point is going to be 2, we go from concave up to concave down. And I know this cubic looks like that because of the negative in front of x cubed. So it all checks out. It all checks out, baby. Given f of x equals x to the fourth minus 6x squared plus 16, where is the function concave up and where is it concave down? Well, the function is concave up when your second derivative is positive. It's concave down when your second derivative is negative. So in order for me to find second derivative, I have to find my first derivative first, and that's going to involve power rule a couple times. Drop down the 4, x cubed. Drop down the 2, multiply it to negative 8, negative 8, 16, x. 16 becomes nothing. Okay, let's find the second derivative. F double prime of x is going to be 4 times 3, which is 12, x squared, and then you become minus 16. Ugh. This is going to be gross. That grunt means it's not going to be pretty at all. Okay. So inflection points. Inflection points exist when the f double prime of x is equal to 0. Okay. So that happens when 12x squared minus 16 equals 0. So let's add 16 to both sides, like you, and you get 16 equals 12x squared. Divide everything by 12, divide everything by 12, you get 4/3 equals x squared. Square root, don't forget your positive or negative, and you have 2 inflection points. Okay, my inflection points exist at the square root of 4 is 2, so they exist, is that supposed to be x? I don't know what I did there. They exist at negative square root of 4 is 2 over root 3 and positive 2 over root 3. So let's go up here and make ourselves a sign chart for f double prime. Okay, my magic numbers are 2 over root 3 negative and 2 over root 3 positive. So if I pick a number like negative 10, if I pick a number like 0 and positive 10, I should be able to plug it into this guy right here and see what I get. So a little bit of math to do here. It's not going to be a ton of fun. F prime of negative 10 is going to be 12 times negative 10 squared minus 16. So 12 times 100 minus 16. Now, I'm not going to freak out about the numbers. I know 12 times 100 is 1200. 1200 minus 16 is a positive number. So you are going to be positive here on f double prime, which means you're going to be concave up because it's positive. So I drew the concave up. I don't know why I did that, but I'm sticking with it. I'm leaving it there. Let's plug in 0. F prime of 0 is going to be 12 times 0 squared minus 16, which is going to be negative 16. You're negative, which means you're going to be concave down. If I plug in positive 10, f double prime, and these are all double primes, f double prime of 10 is going to be 12 times positive 10 squared minus 16, which is going to give us the same exact thing as up here, so you're also going to be positive. So you're positive, concave up. So we could say that this function is concave up on 2 intervals, from negative infinity to negative 2 over root 3, union positive 2 over root 3 to regular infinity. It's going to be concave down in between those 2 gross numbers. So negative 2 over root 3 to positive 2 over root 3. And when we close that off, we get ourselves an answer, and that is how it's done. Gross.